Hey there, kiddos. Welcome to another math lesson. This is Module 4, Lesson 11, and guess what? No notes today because we're going to apply all the things we've been doing with word problems. But we do have an objective. The objective is to solve and create fraction word problems involving addition, subtraction, and multiplication, and that's at the bottom there of your page. At the last one, that's where you get to create your own very exciting create a story problem. So pay attention to how these are worded so that you can more easily create your own problem. So here we go. Kim and Courtney share a 16-ounce bottle of cereal. By the end of the week, Kim has eaten 3/8 of the box and Courtney has eaten 1/4 of the box of cereal. What fraction of the box is left? Now, nicely arranged for us, we have the whole box, then we have two portions that have been eaten. So note that the denominators are different, and if we're going to add or subtract, we have to have the same denominator. So let's set this up with a tape diagram so you can kind of see what's happening here. What is the whole? The whole is 16 ounces. Now when you look at the denominators, okay, how many pieces should we have? It's always better to go with the higher number. 8 is greater than 4. That means the number of pieces. It's better to have like a more definite answer if you can just say, okay, I can always have 2 of the 4s that will make the 8. So let's take our 1/4 and show the equivalent in eighths. Again, I can have an equivalent. 4 times 2 is 8. So 1 times 2 is 2. If you didn't know what I just did, I just used 2 as a scale factor on the top and the bottom. You have to change both the top and the bottom at the same rate in order to make an equivalent fraction. Now let's finish our tape diagram. Showing 8 pieces, because now I have eighths here and I have eighths here. And so here is Courtney, or her equivalent amount, and this is Kim. Okay, so now that we know we have eighths and they have the same denominator, we can label on our tape diagram what everybody has eaten. So let's start at the beginning with Kim eating 3/8. Label that Kim. And then Courtney is 2/8. And let's just put this over here so we don't mix them up. C for Courtney. So it says what fraction of the box is left? Well, not only can you see what fraction is left, and yes, that is true that it's 3/8, but you could also calculate the 3/8 plus 2/8 and get 5/8 are eaten. And also important to know that 8/8 is the entire box, and we're still just talking about fractions, and so then you can take away what has been eaten to mathematically solve and find the 3/8 that you already see in your picture. So 3/8 of the box is left. Okay? We don't have to worry about ounces just yet. A bonus question could be, how many ounces of cereal did Kim eat? How many ounces of cereal did Courtney eat? How many ounces are left? So there you go. See, not too hard. You got this. Click subscribe on the little button right below the video. Click, click, so easy. Come back again, we'll do more math. Matilda has 20 pints of green paint. 20 pints of green paint. She uses 2/5 of it. What is she using? Green paint. To paint a landscape, and 3/10 of it while painting a clover. She decides that for her next painting, she will need 14 pints of green paint. How much more paint will she need to buy? So let's make a tape diagram. It will really help you. Okay, so nice and long. Notice that again we have 5 and 10, which are different just like the top problem, but we're going to use the larger number so that we can have a more precise answer. Divide your tape diagram in half and then put 5 on each side. Okay, so 1, 2, 3, 4, 5, for a total of 10. Now we're going to call the whole 20 pints. Okay, so out of our 10 pieces. We've got the landscape. So let's just make a little note here. That was 2/5, but I have tenths here. Remember, I changed it to tenths. So what can you do to scale up? You can use a scale factor. How do I get from 5 to 10? That's going to be times 2. Whatever you do on the bottom, you do on the top. Don't forget, this is all mental math, or it should be by now. So if 5 times 2 is 10, then 2 times 2 is 4. So the landscape would take up 4 out of 10 pieces. So let's go ahead and shade that. 1, 2, 3, 4. And that's the landscape. Okay. Now for the next part, we've got our 3/10 for the clover. I'm going to, again, do the other shading on the right-hand side. Clover. Okay, because we already had the tenths, we don't have to convert that. It's just 3 out of 10. So I see I've got some paint left, and I have 3, which is the same right here. 3/10 left, but now we're talking about pints. So she needs 14 pints of green paint. So what do I do with this? Well, remember several lessons ago when we talked about taking the whole apart. We would say, well, how many units do you have? Well, I've got 10 pieces. Units is like fancy math talk for pieces. So 10 units equal 20 pints. And if I want to know how many pints are used, I could find out what 1 unit is. Because if I know what 1 unit is, I can know what all the units are. So 1 unit would be 20 divided by 10. And that would look like a fraction as a division problem, 20 divided by 10. So 1 unit is 2. Okay? So if I have 2 pints in each of these squares or little units, okay, because 2 times 10 is 20, that's mathematically what we're getting, then now I can start talking about what she's going to need after she uses all these pints. So how many pints got used? Well, let's look at how many pieces we have here. So we have 1, 2, 3, 4, 5, 6, 7. So 7 fractional units times 2 equals 14 pints used. Okay, but she had 20 pints. So if I take that away from my 20, what does that leave me with? 20 minus 14. So 6 pints. Now that is not enough for the 14 pints that she still wants. So how much more paint will she need to buy? And this is just like save your money. You don't want to have to get 20 more pints because we don't need 20 pints. So you take your 6 pints that are left, and we have the 14 pints that she needs. And that will give you 8 pints needed for the next painting. Okay, so yay, there you go. So I hope that makes sense. Remember, if you find one, you can find anything. And if you know what part of it is, then you can look at what you need, what's used. There's just so many combinations, and you'll probably be asked just about all of them by the end of this year. Okay, next one. I'm going to straighten you out there. Okay, this one's fun. Jack, Jill, and Bill each carried a 48-ounce bucket full of water, and notice that each of them had their own bucket, 48 ounces full of water down the hill. By the time they reached the bottom, Jack's bucket was only 3/4 full. Jill's was 2/3 full, and Bill's was 1/6 full. Poor Bill probably spilled a lot as he was tripping down the hill. So how much water did they spill altogether on their way down the hill? So now you can do tape diagrams. You can go this way, okay? You can also make a vertical tape diagram if it helps you. I'm just going to put one right over here, or maybe I could do 3 right over here on the side if that helps you see what was spilled. So remember, if it's 48 ounces when it's full, but like Jack, his is only 3/4 full, then what are we looking for? We're looking for the spilled amount, 1/4 spilled. So if you think of these as buckets, then that's what you're trying to solve for, is the non-shaded part. Okay, now you can also do it this way. If 3/4 of the water is still there, then 1/4 spilled. Okay, so it's important for you to know like what they're asking you. They gave you a fraction here, but that's not the fraction that we need to work with. You could work with all the fractions they give you, but then you're going to have to subtract at the end. So why do that? Let's just put all together what we are looking for, actually. So here's, that was Jack, and here's Jill, or here's Jill, Jack, Jill. And so Jill's was 2/3 full, 2/3 full, so 1/3 spilled. Okay, 1/4 spilled. Sorry, I'm writing it so many times. Now Bill's was 1/6 full. So if I split it in half and I go 1, 2, 3, 4, 5, 6, poor Bill. He only has 1/6 in, so 5/6 spilled. Now what do I do with all these fractions? Now we're going to go and find a fraction of a number. So you can do this. This is just from a couple lessons ago. Fun, easy. We know what the total is. The total for each bucket is 48. So I need to know what was spilled. So how many ounces? So 1/4 of 48. And you can mathematically solve this by setting it up with 1 times 48 over 4. Remember, it's 4 times 1, so then you get your 4. I don't ever want to do like the whole multiplication. I always want to solve, so I'm going to show you how to do that. Basically, I would shift the 4 under here, divide 48 by 4 and 4 by 4. So I would get 1 here and 12 here, which means 1 times 12 is 12 over the 1, and that's 12 ounces. Ta-da! That's the first one, and that's Bill. Okay, so just circle 1, and then let's move on. 1/3 of 48 ounces would look like this. 1 times 48 over 3. And now what do we do with that? Same thing that we did above. Okay, can we simplify? Now notice that each of these, if I was to go ahead and move it over, I would end up with the same type of division problem that I have here because it's all times 1. Same thing here. Okay, so how many times can you fit 3 into 4? 1 time with 1 left over. Hold that 1, bring it over next to the 8. That would be 18 divided by 3 for 6. So we have 16 ounces for Jill, right? Jill. And finally, 5/6 of 48. Poor Bill. Okay, so we have our 5 times 48. This is going to be a little different here, over 6. Now, on this one, I don't want to do it this way. I don't want to multiply across. I want to simplify here like I did on this one. So shift that 6 over, and it's 48 over 6. What do you get? Well, you get 8. Now 5 times 8, 40. And so you get 40 ounces. Poor Bill spilled almost the whole bucket. Okay, so how much water did they spill all together? This is individually, but now you need to put those all together. It's just a simple addition problem. So squeeze it in over here right next to the spine and do a 12. Line everything up. 16, 40. Line up by place value. 4, 5, 6. 68 ounces spilled on the hill. And that is your final answer. Okay, I hope that's helpful. I hope you can see it smashed in there. All right, last real one that you get to solve before you write your own. So again, pay close attention. Mrs. Diaz. Hello, Mrs. Diaz. Mrs. Diaz makes 5 dozen cookies for her class. 5 dozen. How many are in 1 dozen? You got to know that. Think about it. 1/9 of her 27 students were absent. Wah, wah, wah. They are sadly not going to get to partake in this fun. So 1/9 of her 27 students are absent the day she brings the cookies. If she shares the cookies equally among the students who are present, how many cookies will each student get? Okay, now notice when they say sharing equally, you just know it's going to be division. You have to think about that. Okay, we've got to divide something because it's being shared equally among this whole big group. So, a couple things. We need to count the kids who are absent. It says here that 27 students would make the full class, but 1/9 of them are absent. So we got to start there. 1/9 of 27. Okay, so how many? Put that over 1. Set it up with your 1 times 27 over 9. Notice that you can shift that 9 over. Okay, and how many 9s can you fit into 27? 3. So 1 times 3 is 3. 3 over 1 is 3. 3 are absent. Now that we have solved that, let's take 27 and take away the 3 kids to find out how many kids are present. 27 minus 3 equals, you said it, 24 are present. So 24 students today. Okay? Now, we're going to take this 24. We're going to use that in a minute. But let's go back over to the cookies. Okay, so start thinking about the cookies. She made 5 dozen. Did you think of what a dozen was? Okay, a dozen is 12. So 5 dozen is 5 times 12. Now, you should know, if you can't figure it out, one good way is to do 5 times 10 for 50. And then you need 2 more 5s. So it's 60. So 60 cookies is the total. And now we have to share it between the students that are left. So let's take and make a tape diagram. Call this the whole thing. How many students do I have? 1, 2, 3, dot, dot, dot. How annoying. I don't want to have to count all the way to 24. But here are my 24 students, okay? If I have all these cookies, but everybody's going to get something, then what would I do? So you can take your 60 and divide it by 24 so that we can see the equal number of cookies. Let me back it up a little. There we go. Okay, so 60 divided by 24. Set it up in a fraction so it starts to look familiar. When you get here, some students will jump right in. You can do the long division. You're welcome to do it. But I want to point something out. Remember when we were talking about my rules of simplifying? And I said, you know, if you have a fraction, you can simplify it. Like we scaled things up and we've scaled them down. And I want you to look at how I'm going to scale this down before I do the division because it'll save you a lot of time. Let's say, gee, they're both even. Could I divide by 2? Yes, I could. What if I said, gee, they're both multiples of 6? Could I simplify by dividing the top and the bottom by 6? I could. So when you see something is divisible, choose one of the numbers that goes evenly into both. 60 divided by 6 will give you 10. 24 divided by 6 will give you 4. We could look at this and say, oh my gosh, this is so much easier than dividing 60 by 24. Now there's a higher factor, but probably most people won't know what that is. So let's just go with it here. If there's a higher factor, the greatest common factor, you could simplify in one step. But this is fine for right now. They're both even. Divide by 2, both the top and the bottom. And look at how much simpler it is to divide 5 by 2 than it is to divide 60 by 24. You can do this. If you have to divide it, why not make it simple before you have to divide? So now I have 5 divided by 2, which is 2.5. And I didn't have to do any big bracketed long division or anything. So doesn't that seem like a preferable way to do it? And now we can just label 2.5 cookies each. And we're done. How about that? Pretty cool. Anyway, the last question. Okay. This is you. I'm not doing it. Okay. Create a story problem. You create a story problem, that means a word problem, about a fish tank for the tape diagram below. Your story must include a fraction. Now, we've been dealing with fractions all throughout, okay? And I've been pointing out, well, what's the whole? So you need to know that this is going to be the whole. So it might be all the fish that you would have in the tank. That makes sense, okay? And when thinking about a fish tank, if you've ever seen one, if it's a really big one, you might have several different types of fish which could resemble the tape diagram. Now, how many different pieces are in here? This is going to be an important number in your problem. Okay, so remember how many pieces, that's going to be an important number. The location might be the denominator, but I didn't tell you that. Now, the numerator might be the selected number of pieces. Okay, so pay attention to the number that is set aside or set apart with the question mark, because that's what you're trying to solve, okay? Also pay attention to the total number of pieces in the tape diagram. That's the denominator, and then this is the whole. So it looks like it's a fraction of a number for you to solve. The rest of it's up to you. You decide the type of fish, how pretty they are, whatever, they're living, they're not living, it's up to you, and it's your story. So you write a word problem, okay? You can think about Nemo and the fish in the tank, all the fishes in the tank with him, and think of your own story, okay? So that's the last part of today's lesson, and you are on your own for that. Come back again for future videos, and we will see you on the next one. Bye for now.